Hello everyone, this is day 11 of DSA problem solving challenge, and today I have solved a problem which is 205 from leet code, which is isomorphic strings. Here we have problem given two strings S and T. Determine if they are isomorphic or not. Means we have given two strings, we have to check is these two strings are isomorphic or not. Two strings S and T are isomorphic if the character in S and can be replaced to get T. Means here we have two string S, already we have written that, and we have to check if string S character should be replaced by string T character. All occurrences of a character must be replaced with another character while preserving the order of characters. Means we have to replace one character from the another character, follow one sequence. No two characters may map to the same character. Means no two character should be having same values, but a character may map to itself. Means a character should have its own value also. Here we have example 1. Input S equals to EGG, T equals to ADD. Means here E is replaced by A and G is replaced by D. So this is true. And here we have another example. S equals to F11, T equals to B23. Here F is replaced by B, 1 is replaced by 2, and another 1 is replaced by 3. That should not be possible. Means if here we have replaced 1 with 2, then again we have to replace 1 with 2 only. We don't have two values of same character. So this is false. And here we have another third example. S equals to paper, T equals to title. If we talk about P, we replaced it by T, and talking about A, we replaced it by I, and talking about another P, we replaced that P also with T, and if we talk about E, we replaced it by L, and talking about R, we replaced it by E. Means here each character is replaced by another character. So this is true and followed a sequence. So this is the problem. Let's move to the logic. Talking about the logic for the problem, here we have S equals to EGG having 3 characters and T equals to ADD. First we have to check the length of the string. If the length of this string is equals to this string, then only we move forward. We have to check for these two strings. Here we will use the concept of hash map. Means we will create two maps, M1 and M2. M1, this side we will write the string of S, and here we will write the string of T. First we will assign E with A, which is given in the string E at the S and A at string T. So here we have already assigned E with A, G with D, G with D, and here we will assign string T to string S. So here A is assigned with E, D is assigned with G, D is assigned with G. So here we will check for the conditions. If this is assigned with A, then again if we are having E, then same type of assignment should be there. Means if E is assigned with A, then another E will not be assigned with any other characters. So this will be wrong. Here we have G, which is assigned with D, and again we are having G, which is assigned with D. If G is assigned with anything else like A, then this is wrong. Means it will return false. But in this case, E is assigned with A, G is assigned with D, and here also G is assigned with D. So this is true. Means it is isomorphic string. Here again we will check for M2. A is assigned with E, D is assigned with G, D is assigned with G. So if A is assigned with E, then again the same type of assignment should be there. If A is there, here D is assigned with G, so again D should be assigned with G only. So here D is assigned with G, so it will return true. If we talk about another example, here S equals to F11, T equals to B23. So we will write this in the hash map. F is assigned with B, first is assigned with first, 1 is assigned with 2, and 1 is assigned with 3. So here we will check if this is possible or not. If we talk about f is assigned with b, that is true. Here we have 1 which is assigned with 2. So again, if 1 is there, then it should be assigned with 2 only. If this is not possible, then we will return false. Here 1 is assigned with 3. This is not possible, so we will return false over here. So talking about the pseudocode of this problem, so first we will take to map m1 and m2. Here we will assign the string s character to string t characters. First we will check the length of the string s with string t. If this length is not equal, then we will return false. So talking about the condition, first we will use here for loop, which it starts from I equals to 0 to string length, up to string length, and we will increment the value of I. So here is the condition: m1 dot find s of I not equals to m1 dot end. If m1 dot find means character at si is not equals to m1 dot end, means not there in at the end, then we will move inside this condition. Here another if condition is there. If s of I is not equals to t of I, means if we have a tends to b, again we should have to there we have to check for a tends to b only. If this is not equal at the next time, then we will return false. Next we will check for else if. This will check the second hash map, which is m2. Here we will start from the ti. T of I not equals to m2 dot n, means t of I means any number is not equals to any character, means any character is not equals to any character, means assignment is not proper. Then we will move inside. If m2 t of I not equals to s of I, means if a, then there should be a tends to b again after that only. But if this is not possible, we will return false. If the mapping was not done for si and ti, then we will assign a mapping over here. m1 of si equals to t of I and m2 of ti equals to s of I. If this condition is not followed or any condition doesn't return false, then we will return over here true, means the strings are isomorphic. So this is the logic. Let's move to the coding part. So talking about the coding part, here first we will create the map to map m1 and m2. Here we will check the length of the strings. If s string length is equals to t string length, then we will return. If that is not possible, we will return false. Here we will start from I equals to 0 to I less than s dot size, means string length, and we will increment the value of I. If m1 dot find not equals to m1 dot end, means s of I not equals to m1 of end, then we will move inside this loop. If m1 si not equals to t of I, means if a tends to b is there, then every time we have to check for a tends to b only. If that is not possible, then we will return false. Here we will check for else if condition for m2 hash map. Here we will have t of I. That should not be if that is not equals to m2 dot end, then we will move inside that condition. Here we will check for b. B is assigned with a. Then every time we will check for b assigned with a only. If that is not possible, then we will return false. If mapping was not done for si and ti, we will map mapping for that. And if this condition doesn't follows, then we will return true. So this is the coding part. This is day 11. Thank you. Bye bye.